We are continuing section 4.3. This is day 2. We didn't quite get to the quadrantal angles yesterday. These are angles where the terminal side lands on an axis. Okay, they call them quadrantal angles. For these angles, we cannot produce a reference triangle, but it will be easy to either pick a point or be given a point on an axis, and we can still think of our x, y coordinates, our r value. All right, we can still manipulate that formula. So our first one says find each of the following if it exists. If the value is undefined, just write undefined. Now, we're not finding all 6 trig functions here. We're just finding a single one, but you certainly could extend it to find the other ones. Okay? So the first thing I would do is draw your axes and figure out where that negative 270 would land. Which axis does it land on? Positive or negative? So positive y-axis. So we're going from here all the way around to here, correct? That's negative 270 degrees? Okay. If you had to pick a point, because they didn't give us a point on that axis, but we can find some, right? If I picked the point 0, 4, okay? Let's say we pick the point 0, 4. Well, I know my x coordinate is 0. I know my y coordinate is 4. What is r? R would be 4, right? Because r is the distance from the origin to your point. It's right on an axis, and we just measured it to be 4. Could I pick 0, 10? Could I pick 0, 50 million? If I wanted to have a lot of fun, I could. But what would be the easiest point to pick? 0, 1, right? That's the shortest, closest whole number. So it makes sense to just define this as the point 0, 1. Okay, so regardless of what axis we land on, we can measure out 1 unit from the origin, and that would be the point we would use. Okay, now we can't draw reference triangles for this, but we still can think of our definitions. Sine, we said, was defined as which letters? With using x, y, and r. Y over r. Okay, so in this case, our y value is a positive 1. Our r value is 1. So we get the sine is 1. Okay? What would happen if we wanted cosine? Cosine would be 0, right? 0 over 1. What about tangent? That would be an undefined situation because tangent is y over x. If we put 1 over 0, we have trouble, right? Can't divide by 0. So that's why they're saying sometimes it might be an undefined answer. Okay? All right, let's go ahead and sketch. Where would the angle 3 pi be? So 3 pi, we're going in a positive direction, right? Every 180 degrees is 1 pi. So our angle here, there's 1 pi, 2 pi, 3 pi. We're landing over here. Okay. So what's a good point that I can pick there? What would my coordinates be? Negative 1, 0. You got to watch the direction, right? We're going left 1. So negative 1 is my x value. 0 would be my y value. What is my r value? R is still 1, positive 1, right? And when we talk about the unit circle in the next few days, we're talking about a circle that has a radius of 1. Okay, so that's kind of why we're tying this all in with r being 1. All right, we want the tangent. Tangent is defined as which letters? Y over x. Sine over cosine is another way to think of tangent. Okay, sine is y, cosine's x. Y divided by x. So now I have 0 divided by negative 1, but 0 divided by anything is 0. So I would say the tangent of 3 pi is 0. Okay? What makes this next one a little trickier? It's secant, right? We're kind of getting used to the whole sine, cosine, tangent stuff. Now we throw in secant. Secant is the reciprocal of cosine. We define cosine to be x over r. So secant is going to be r over x. Okay. Now, you can always find the cosine and then flip your answer if you want to do it that way as well. So take a second and figure out where 11/2 pi would land you. I'm going to pause the recording, let you try this one. All right, so 11/2 pi. You can do this a couple different ways. How far would we go in our rotation for 1/2 pi? 90 degrees, right? One quadrant. So I basically have to spin through 11 quadrants, right, to get 11/2. So that's one way to think about it. 11/2 as a decimal would be what? 5.5 as a mixed number, 5.5, right? So we want 5 full pies plus an extra half a pi. Okay, so here's 1 pi, 2 pi, 3 pi, 4 pi, 5 pi plus an extra half. Yes? We should be landing on the negative y-axis. So what would the coordinates be of a point down here? 0, -1. Okay, so if I have to do r over x for secant, we said r is always going to be 1 as long as we go 1 unit in whatever direction we have to go. Our x value is 0. So can we take 1 divided by 0? No. We would say this is undefined. So the secant of that angle is undefined. Would the cosine be undefined? No, cosine would be the reciprocal, right? So instead of 1 over 0, you'd have 0 over 1. Okay. The more we start working in all 4 quadrants as opposed to just being in that first quadrant, the more you really have to think about, is x positive or negative in this quadrant? Is y positive or negative in this quadrant? That's going to help you figure out, first of all, which quadrants you need to be in. All right? Now, my picture here, I apologize. I'm missing some font that's creating those symbols. So what you should have on here is plus and minus signs. Okay? So some of you have boxes, some of you have blanks, some of you have the plus and minus signs written in. We're just going to make sure it all matches. All right, so let's start in quadrant 1. Okay? Quadrant 1, cosine is positive because cosine is which letter? Cosine is x, right? Cosine is x. Sine is y, right? So in quadrant 1, cosine is going to be positive because x is positive. Sine is going to be positive because y is positive in this quadrant. Now tangent of theta is defined as what? Tangent of theta is actually sine over cosine. You're going to start memorizing that one as well. All right, or y over x. Well, if x and y are both positive, a positive divided by a positive is positive, right? This x is just labeling my axis. Okay, let's move to quadrant 2. Quadrant 2, cosine, which uses which letter? X. Cosine would end up being negative in quadrant 2. All right, how about sine? Sine is still positive because y is positive in this quadrant. Tangent, though, divides the two, right? So if you have one positive and one negative, you're going to end up with a negative answer, okay? So tangent of theta is going to be negative. Moving to quadrant 3. What happens now to my x and y coordinates? They're both negative. So cosine uses x, that's negative. Sine uses y, that's negative. What about tangent? Now we have a negative divided by a negative, so we're going to end up with a positive here. Okay? Go ahead and take a minute and complete quadrant 4. All right, let's check our answer. Cosine in this quadrant is positive. Sine is negative. Tangent is negative. Okay, are we good with that? All right. Our next example, it says using one trig ratio to find the others. Now, you're going to be given enough information that you can figure out what quadrant you have to be in. And you're going to be given enough information that if you know two sides of a triangle, you can find the third. Yes? Okay, so this is really a lot of analyzing the information you're given to make sure you're landing in the right quadrant. First thing I see, well, it says to find cosine and tangent. We're not going to find all six. We'll just find the three main ones, because once you know those three, you can just flip them over, right? So find cosine and tangent by using the given information to construct a reference triangle. I would expect to see a picture drawn, and it's important that you put the triangle in the right quadrant, okay? So the first thing I'm being told is that the sine of theta is 3/7. That's a positive 3/7. So think about our coordinate plane. In which quadrants would sine be positive? Think about it. In which quadrants will my sine be positive? 1 and 2. Okay, so sine is positive here and here. Yes? Then it says, but the tangent has to be less than 0. So the tangent has to be negative. Well, tangent is y over x, right? Sine over cosine. So if we know sine is positive, but tangent has to be negative, it's telling me what? Why would it be in the second quadrant? What's negative? Okay, now, I don't want you flipping back to that chart we just drew, right? With the plus and minus signs. I want you to be thinking about it, so you don't have to reference that all the time. Tangent is sine over cosine. We're told sine is positive, but this tangent is supposed to come out negative. That means cosine has to be negative. Yes? My r is always going to be positive, so I'm just dealing with my x and y's, trying to figure out which one's which. So I have to be in quadrant 2 to have a positive sine but a negative cosine. Agree? Okay, so we are going to draw a reference triangle in quadrant 2. We always have one line on the axis, the x-axis, right? We want this reference angle. Okay? So my original angle theta is really this, okay? But I'm using the reference angle to find my trig values. We're told the sine is 3/7. That means I have two of my sides that I can label on my triangle. Okay? We said sine was y over r. Okay, so 3/7. My y coordinate would have to be 3, and my r value would have to be 7. Does that make sense? Okay. Can we find the missing one, the x value? Yes, we're going to use the Pythagorean theorem. Okay, so x squared, our missing one, plus 3 squared has to be 7 squared. Okay, so x squared would have to be, what, 49 minus 9? 40? Which means x is going to have to be the square root of 40, plus or minus, but we know it's going to be what? Cosine's going to be negative, right? X is negative in this quadrant. So I know my answer is going to be the negative version. And what can we do with root 40? Simplify it to what? 2 root 10? Okay. So now we can dump that in here. This is going to be negative 2 root 10. Okay? They asked me to find cosine and tangent. All right, so now that we have our triangle labeled, the cosine of my angle is my x coordinate over r. So negative 2 root 10 over what? 7. Okay. My tangent is y over x. So 3 over negative 2 root 10. All right, if we rationalize that, we'd have to times by a root 10. So we would get 3 root 10 over negative 20. Okay. So talk at your tables about this next one. We're told the secant is 3 and the sign has to be positive. Just see if you can figure out what quadrant you should be in. All right, so secant is the reciprocal of what? Cosine. So if I'm given secant, cotangent, or cosecant, first thing I'm going to do is flip them over. All right, because in my mind, sine, cosine, tangent, I use those more. I'm more familiar with them. Okay, so I'm going to think of this as telling me that the cosine is 1/3. Okay, cosine is positive and sine is positive. That has to be quadrant 1. All right, so let's draw our triangle. We're in quadrant 1. Okay. We can label 2 of our sides. We know cosine is x over r. So x is 1, r is 3. Can we find our missing side? So 1 squared plus y squared has to be 3 squared. We good with that? Okay, 3 squared is 9, subtract 1 is 8, y squared is 8, which means y is going to be the square root of 8, which is 2 root 2. And is it the positive or negative version? It's the positive version. All right, so we have a 2 root 2 there. All right, so cosine we are given, cosine we figured out already. Tangent, what would I say for the tangent of theta? Y over x, right? So 2 root 2 over 1, which is 2 root 2. Okay. Third example. This time we are told the cotangent is undefined and the secant is negative. The cotangent is undefined. What does that tell us? It's going to be on an axis, right? Because that's where we land on running into trouble with having 0 for a side length. All right. If cosine is undefined, then, cotangent, then tangent would be what? So cotangent, we can think of as 1 over 0, right? Undefined. So tangent is going to be 0. All right, and tangent is y over x. Yes? But now we have to figure out which quadrant helps us with that secant being negative. If secant is negative, then cosine has to be negative. All right, so talk at your tables. What axis are we talking about here? All right, so cotangent we said was undefined, meaning we're on an axis. Secant is negative, which means cosine is negative. We have to be over in the left half, right? Quadrants 2 or 3. The cotangent piece tells me I'm right on this axis. Okay, so let's define a point there. What would our point be? Negative 1, 0? Okay, so they are asking me to find which two? Cosine and tangent? Okay, well, we already found tangent, right? Tangent for our angle here would be y over x, so 0 over negative 1, or just 0. And cosine is going to be what? Cosine is x over r, so negative 1 over 1 or just -1? All right. Questions on how we kind of reason through what quadrant we should be in? We doing okay with those? Is it harder when it's a quadrantal angle? When it's on an axis? Like, was this last one harder? A little bit, trying to figure out which one's the 0, which one's... Okay. Well, luckily, you're going to have some practice in your homework on that. No? Not luckily? All right. So, trig functions. We've found trig functions of basic angles. We are going to look at what happens if we use radians now. So trig functions for any real number. We have to think in radians so that our inputs and outputs are all real numbers, okay, instead of degrees. The unit circle, I've been referring to that several times over the last few days. It's defined as a circle of radius 1 centered at the origin. Okay, so pretty much your most basic circle that you can draw. Arc length along the unit circle corresponds exactly to radian measure. I want you to think about that for a minute. We talked about 1 radian. We talked about 1 radian being an angle where we would measure off along the circumference, right? Whatever that radius is. Yes? So if we've defined this as our unit circle, its radius is 1. So when we measure off 1 space along the circumference, right, that's 1 radian. Okay. The unit circle can be used as a kind of number line using a wrapping function. In other words, if I were able to take a ruler or tape measure and curve it, okay, I can start with it right here and just start wrapping it around going in the positive direction. Or if I wanted to, I could go in the negative direction, right? And if I lay that tape measure along the circumference, right, I basically can figure out how many radians I've moved. Okay. All right, so that's what our picture here shows. Okay, we've got a unit circle. It has a radius of 1. We're taking that tape measure, all right, and let's say we have point T they used, and we're marking off T radians. Okay? So if I have T radians, and let's say my tape measure is in inches, I would say if my radius is T inches, then I'm going to mark off T inches along the circumference. Yes? Again, we can do that in a positive direction. We can do it in a negative direction. You're just wrapping that tape measure around it. And again, we have defined our unit circle to have a radius of 1, so it's going to make things a lot easier. Now, in this next picture, our point P is labeled cosine T, sine T. Why? Okay, but cosine is defined to be x over r. But what's r? In a unit circle, r is 1, right? So that's why I've been saying all along, if you can memorize cosine's x, sine is y, right? In a unit circle, r is always going to be 1, so that's going to drop out of our calculations. Okay? So, our cosine is x. That means our x coordinate along that unit circle, the x value, is going to represent the cosine of our angle. Okay? Same reason for sine. Sine, we said, was defined as y over r, but if r is 1, we just get y. Okay? So I can measure off say, a 30-degree angle, which would be how many radians? 5 or 6 radians? Okay. That means the coordinates of that point, that's a 30-degree or pi over 6 radian measure from the x-axis, my coordinates, the x value is going to be the cosine of pi over 6, or the cosine of 30. Okay, think about your 30, 60, 90 triangles. What's the cosine of 30? Nope. Cosine of 30. Okay, let's draw our picture. 30 degrees, right, or pi over 6. Opposite side is 1, hypotenuse is 2, other edge is root 3. So the cosine would be root 3 over 2. Okay, sine of 30. That's the 1/2. Yep. All right, so there's a point on my unit circle. You're going to have points for 30 degrees, 45 degrees, 60 degrees, 90 degrees, and you're going to keep spinning around all the way around, right? And you're going to know them all. There's an easy way to do it. If you know quadrant 1, you can do the other quadrants. And if you know one of them, which is why I told you guys start thinking in your head here, sine of 30 is 1/2, right? If you know that, you can create them all. Okay? When trig functions are applied to real numbers, they're usually called circular functions because we're thinking of that unit circle. Okay, we're just rotating around. All right, so some of this we're going to do together. Some of it I'm going to have you work in your groups. The first thing, it says, get together in your groups of 2 or 3, explain to each other why these statements are true. Base your explanations on the unit circle. Remember that negative t is going to wrap in the same distance, but in a clockwise rotation, as opposed to positive t going in a counterclockwise. But you'd land in the same distance from where you started. Okay? All right, so first one we'll do together. Oops. For any value of t, the value of the cosine of t is going to lie somewhere between -1 and +1. Okay, so how I would reason through this, cosine is which variable? X. Cosine is x. So thinking back to a unit circle, okay, think about your x coordinates. At this point here, what is my x value? 1, 0. Okay, what's my x value over here? Okay, so x is 0 there. Here it is -1, and here it is 0 again. Okay, so looking just at my x coordinates, I went 1, 0, -1, 0. What is it here? Root 3 over 2? What's root 3 over 2 as a decimal? Somebody with a calculator, quick. Root 3 over 2. Now think about it, 0.866, right? If this space is 1 and I only go to here, right? It's got to be smaller than 1. Yes? To get up to this point, I haven't moved at all from 0. Okay? To get to this point, well, I've moved a little bit in the negative direction, right? But I haven't gotten all the way to -1. So is it reasonable for us to say that the value of the cosine of an angle on our unit circle is going to somewhere be between -1 and +1? If you just think about where you move on your x-axis to get to any point on your unit circle. Yes? Okay. Would that same reasoning hold true for the sine as well? Okay. So at your tables, I want you to try number 3. The values of the cosine of t and the cosine of -t will always be equal to each other. Take a minute and talk through that. The cosine of t and the cosine of negative. So my suggestion for number 3 was to substitute a number in there if it helps you to think of a number t. Okay, so let's think about a unit circle again. Okay, and let's pretend we go a positive 30 degrees, okay, versus a negative 30 degrees. Okay, thinking about the coordinates of your point. We've got this one and this one, yes? They are on the same vertical line, correct? So this is just one vertical line connecting those two dots, which means the x value is going to be the same. Agree? So the cosine of some positive angle is going to be equivalent to the cosine of its same measurement but going in the opposite direction. Okay? Question 4. The value for the sine of t and the sine of negative t will always be opposites of each other. Well, we can use our same picture, but now sine, we're talking about what? We're talking about y coordinates, correct? So let's think about our y values. Okay, so the y coordinate here and the y coordinate here, right? We're going the same distance but in opposite directions. So we'd have opposite answers. Okay? All right, so the sine of t is going to be what? It's going to be the opposite of the sine of negative t. Does that make sense? Okay. All right, using the same reasoning, think about your unit circle, draw it out if you have to. The values for the sine of t and the sine of t plus 2 pi are always going to be equal. In fact, this is true of all 6 trig functions on their domains and for the same reason. So we're just going to work through it for sine. Okay? So for number 5 here, there's my unit circle. Okay? And I'm going to draw angle t. Okay? My sine would be my y coordinate. Okay? Okay, I'm just going to call this x and y. Okay? Well, where do I land if I go to draw the angle t plus 2 pi? I land in the same place, right? Adding 2 pi just means we've done a full circle rotation. So my other angle, even though I'm going to spin around an extra time there, I'm still going to have the same terminal side, which means I'm going to have the same coordinates for my endpoint, which means my y value is going to be the same. Okay? So those would be coterminal angles. You're landing in the same spot, you're going to have the same coordinates. All right? Question 6. The value for the sine of t and the sine of t plus pi will always be opposites. It says this is true of cosine as well. So think about that. Where would you land if you go angle t? We can use the same one I already have drawn here. But where would I land if I do t plus pi? That's half of a rotation. So I'm going to land in the diagonal quadrant. Okay. So let's get a different color here. So now instead of being here at the black angle t, I would be down here. Okay, so this angle would be t plus pi. So if in quadrant 1 my coordinates are x, y, in quadrant 3 down here my coordinates would be negative x, negative y. All right, so your sine is going to be its opposite, your cosine is going to be its opposite. Number 7. The values of t and t plus pi will always be equal. So for sine and cosine, we said they are opposites. But for tangent, we're saying they're going to be equal. Why? Because that's the rule. But why is it the rule? What are the variables we use for tangent? Y over x? Okay, so for angle t, the tangent of t we have is being y over x based on my point here. Okay, so what's the tangent of t plus pi going to be? Now I'm down at my quadrant 3 point. So negative y over negative x, but dividing two negatives cancel each other out. Yes? Okay, so for sine and cosine, our x and y is flipped to being opposites, but then when we divide them, our tangent ends up being the same. Okay? We're going to talk more about that, that topic tomorrow, and it's called the period, and when we go to graphing, it's going to be really critical. So for sine and cosine, we would say the period of it is 2 pi, because I have to spin a full rotation to get back to having that same x and y coordinate. Okay? But for tangent, I can spin just a half a rotation and still end up with the same tangent values. So the period for tangent is only pi. Okay? We'll talk more about that. Question 8. The sum of cosine squared plus sine squared is always going to be 1. Think about that. Cosine squared plus sine squared . What cosine is what letter? I'm asking you this how many times today? So you keep memorizing it? So this is x squared. Okay, sine is y. And they're saying x squared plus y squared equals 1. Well, let's think about our unit circle again. X squared plus y squared equals 1 squared. What is that? Pythagorean theorem, right? On a unit circle, radius is 1. X squared plus y squared is always going to equal 1. That's one of our trig identities. Cosine squared plus sine squared is always 1. All right? You'll have that memorized by the time we get to chapter 4. Or chapter 5, I mean. All right. The challenge question. Can you discover a similar relationship that is not mentioned in our list of 8? We've been talking about sine, cosine, tangent, right? Come up with something, maybe using the other 3 trig functions. All right? Piggyback off of one of the statements we have, but convert it to a secant, cosecant, or cotangent. All right? Go ahead and talk at your tables about that for a second.